Good morning. How's everybody doing? Good, awesome, great. Me too, I was just telling Lionel and a bunch of guys that I took a red eye to be here, so I apologize if I have red eyes. My name is Evan Statton. I'm a solutions architect with AWS Elemental. We're going to talk about machine learning and media today for a few minutes. Machine learning is solving some hard problems in computer science, and here's a couple examples of what we're doing. You try to learn, you try think about language perception, problem solving, and reasoning. And the way to do it in general is that you create a model, right? You have to say, I'll use the example of a cat because in our company we like to find cats in videos automatically. I'll show you how to do that in a few minutes. But in general, what you would do is you would build a model, and in this case you would present a picture of a cat, and you'd tell the machine, this is a cat. And it's going to go through and it's going to look at that and try to find patterns, right? And then what you're going to do after that is you train that model. So you give that model a whole set of training data, like pictures of things that might be cats or not cats or whatever you're training it to be. And probably on the first pass it gets a lot of stuff wrong, but that's why we're training it, right? So when what it finds is different from the reality or the expectations don't match, that's the tuning stage over here. So it tunes it, and that's sort of a repeating loop. You train it, you tune it, you train it, you tune it until you have something that you're pretty confident that can find a cat in an image or do whatever it is that you've intended to do, and then you can deploy it. Amazon has a number of things in the ML portfolio. Each of these represent certain models that we've trained over time, and as they get good enough, we deploy them to the market. But today I'll be focusing on 4 of them that I think are relevant here to media and entertainment. That's the comprehend, recognition, transcribe, and translate services that AWS offers. I guess a quick definition of these, if I might. Comprehend is going to discover insights about your content. Usually it's going to be text-based, right? So you send it a list of text data, and it'll find interesting terms in the text that it think go together and have some relevance. Recognition is going to do some video and image analysis, tell you what's in a frame, for example. Transcribe is speech to text. So you can imagine now, you start to combine these things. If you do speech to text and you comprehend, then maybe it's telling you something that somebody is saying, and you could use that as metadata. And that's sort of the point of this presentation. And then the last one is translate. Once you have the text in one language, let's call it English because we're in New York, but once you have it in English, then you could translate it to any number of languages that AWS supports. In general, the way it works is that you're going to ingest a piece of media, and then you need to distribute it. So what happens in the middle is processing and metadata manipulation. So in this case on the left, and this is just a general visualization of how this works. We'll go into detail in a minute. But basically, you're going to take in a live feed or a file. You're going to probably convert it into another format such as JPEG images or audio in this case. You're going to run some of the ML services, and then you're going to store them in a database, right? So now you have rich metadata stored in a database that you have associated with certain frames of video. And then on the way out, you can combine it to create a deliverable. Think about automated closed captions or something like that, right? You're going to transcribe what somebody's been saying, like an announcer. You store that, associate it with the frames of video, and then on the way out, you can time that and map it to auto, put the text in at the right place. That's just one example. We talked about recognition, transcribe, and translate briefly. I also want to mention Lambda, Media Convert, and Media Live, which are 3 other AWS console services that sort of round out the suite of services we're going to talk about here. Lambda is code on demand, essentially, right? You don't need to manage an instance in the cloud. You can just have a function or a program that you'd like to run trigger with a certain event. And then media convert is a file-based transcoder. Media live is a live video encoder. Here's a slide on media convert. Like I said, it's a file-based transcoder. It has professional-grade features and quality, and I'm not going to read all the points, but the one at the bottom I think is interesting for this conversation, and it can output images or video to recognition and audio to transcribe. So that's sort of the first step in getting some automatic machine learning data going, sending it to those services in the first place. Recognition is that image or video recognition service that's out there. We've trained the model over time to get better at doing these things. Here you see a scene. It's 99% sure that that's a person and 83% sure that we're outside, for example. And over time, the service gets more and more accurate. You have publicly available options in the service, and you can train it yourself with your own set of images if you want. But for example, something like celebrity recognition, that's available to everybody. So if you had a piece of content and you wanted to run through it, you could say, hey, tell me all the celebrities that are in here, and it'll give you back time codes and celebrities and their location in the frame. And the video recognition part at the bottom is the same thing, except it also does activity and person tracking. So if a person is to move, it can track where that person went over the course of the scene. Transcribe, real quick again, it's going to output JSON with the full transcription and word timing. So you essentially give it a WAV audio file or an MP3 or something like that, and it'll return to you, all the words it finds. It does so with a confidence score, and I'll show you that in a minute. Basically, it can either be very, very sure that somebody said a certain word, or maybe not so sure. So when we talk to customers about the service, we say everybody has to define the threshold of what they want to accept, essentially, and maybe flag stuff that's below, I don't know, say 50% or something like that. You say have a human take a look at it, but you can help automate QC processes that way, if you will, too, because you can also add a custom vocabulary, for example. What's it, the 9 words you're never supposed to say on TV, right? There's probably more words than that now. These are a couple of the use cases that we've talked about so far, right? We can do clip production using recognition to find people and actions. Auto caption generation is one. And creating ad pods in media for more effective monetization. I don't have a demo at the bottom, but I'll show you demos of the top two. I'll just give you an example real quick of one, right, that we talked about. If you start with a file on the left here, you want to create some metadata from it and use it, right? So you drop it into media convert, and media convert converts it and drops it into S3. Now, when it drops it into S3, you can have something called a S3 notification. It's essentially, I got a new object. What should I do with it? And in this case, you can trigger a Lambda script is one of the common things you do when you see an S3 notification. And that's one of those, script on demand. So it's, okay, now I'm going to do something with that object that just got dropped in the bucket. In this case, I'm going to send it to recognition automatically. Recognition's going to do its celebrity detection or what have you, and it'll drop it in a database. So that's sort of the idea of how you can piece together the AWS microservices into something hopefully useful to your organizations. Now, I wanted to show you a demo, and I just realized, does this laptop have internet? Do we know? It does? All right. So I might pop out of the slide deck for a second and bring something up. Forgive me. I thought I'd be using my own laptop. Okay. Let's give this a shot. how do I get this over there? Uh-huh. These are some NAB demos we had. I figured it was better to see something in real life than me to just show you slides, but we'll do both. You can look first at the, can everybody see this? Maybe? There you go. Okay, so in this case we have a hockey game that's being played. This is a live feed coming in. And what we're doing with it is using the scoreboard data to find points of interest during the program, right? So if the scoreboard were to change from 0 to 1, for example, you might think that somebody scored a goal. In fact, probably somebody did score a goal if something like that happens, or the scoreboard operator made a mistake, but probably a goal. So, you know, for example, at this point here, if you can see it, it went from 1-1 to 1-2. So if you click on that, it'll load a feed of somebody scoring a goal, right? Hopefully. There it is. And that was all done automatically, right? Just by, you know, OCR type of stuff in the recognition algorithm. And it'll go and generate clips here, and because the cameras are all, you know, lined up in time code, you can get different angles of it, right? Like here's the opposing goalie, what have you. So in this case, what we're doing is, can I go to slideshow? Yeah, here we go. It's similar to what we looked at before, right? So the media live service is encoding, it's dropping stuff in S3. S3 is sending it down to recognition, right? In this case, it's using the scoreboard as a way to key Lambda events, which is to trim it, right? To say, I need to start and end, and then it's publishing it to the user interface, and then up to the packager and CloudFront to distribute out to you. So you can probably be creative and think of any number of examples where that might be useful. Looking at scoreboards or text or something to trigger events. That's one. The other one is an automatic closed caption and translation service that I'll show you in a second. In this case, it starts out the same, right? The live stream is going to go down into S3, hit to recognition, and this time, you know, over on the right, you see here a few of the text services that we have. So it'll do the transcription, the audio to text, and then it will translate it into a few different languages, and then it'll try to comprehend it. So it'll look for certain patterns in the data and say, you know, try to give you a hint about what it's about, which could be useful. So, oh, see, it works much better the second time around, huh? Here's the transcribe and translate. So here on the left, I apologize that it's small, but here's a live thumbnail coming in. And the first thing that happens is it transcribes it. Let me scroll down a little bit so that you can see. So somebody's talking here. I can't see it myself. It says, well, I think for 2018, I'm just going to something, something, something. But the point is that it was auto-generated there by the transcription service. And then it was translated into like 7 different other languages. So here's, what is that, French? Lionel, is that accurate at all? It is accurate? Well, that's good. We asked, I think we asked Chris Zhang the other day if the Chinese was accurate, and mixed results, but the...
Is that perfect that you can understand?
Yeah, thank you. That's good. So, and you know, Spanish, I think there's the Chinese, right? And they do Arabic too. So, you know, it has all these languages built in and dictionaries and everything, and it'll do that for you automatically. I think somebody pitched the idea of a service that would then use the text-to-speech, the Poly service, to give you automatic, audible translations of what's going on there, which is pretty cool. For comprehend, the idea was that it's going to find patterns in your texts that you might want to store to see what they're talking about. It essentially finds phrases, right? So this is key phrases. It says, my dog, or has a very nervous bladder. I don't know what they're talking about there, but the Salvation Army tournament. Like it just finds logical phrases, and then you could store those as possible topics, what they were talking about. Another one that they did was quantity. They look for things with numbers, right? So it says, 1 square chain, or 99th year, that type of stuff. Just another form of phrases. The last one was dates. So you can find next year. They said next year a couple times. That's a couple things which you can do. And then in recognition that they're running, it keeps finding new stuff. I think it does it every 10 seconds, it updates. These are the labels that it found in the frames of recognition. So, it found a crowd, it found some flowers, pots, pottery, what have you, right, just by looking at it. It also found some faces that are happy, angry, sad, think of all the emotions. I'll show you an interesting one that we had. Hopefully this one works too. This one was about tracking players who were playing soccer or football, wherever you're from. And in this case, I hit play here. Here's the sports clip. And you can see that it's identifying people, putting boxes around them, and then tracking them as they go on the field. Now, as it does that, it can be dumping that information into a database for you automatically. And then you could use it for various things. For example, there's this guy, Tomas. I think he's the goalie. And if you click on him, it jumped to him, right? They're what does that say? 98% sure that that's Tomas, right? So you can essentially give it, a bunch of people that you want it to be able to know about, and then you give it a video clip, and it'll find those people automatically, and you can create, subclips or be able to jump to it. Here he is again at the end. I see it in red, right? So it found him standing there again. As you see, it's pretty accurate, right? It did it pretty quickly. Obviously I'm not going to go through all the players here, but you could imagine how it would work. I think the last sort of interesting thing that we made this thing do is find details in faces and emotions. So some of the models that we've trained are starting to get pretty good at this. So smile, apparently a lot of people are smiling here, right? So if you maybe find something interesting. Maybe we think that this guy is smiling. I don't know, that's not I wouldn't consider that there we go, yeah. If you jump around, maybe you find people smiling. And then the other one is over here, emotions. So let's find angry. Angry is emotion. Oh, there's Tomas again. He looks angry, right? So you can get the sense of what's going on. I like the bar graph. And by the way, this is just all stuff that we did internally to build what we wanted to see. The bar graph is kind of useful because you could see that most people are happy, right? Maybe they're happy to be at the football game. So you might get the overall feel of a scene if you were to do something like this, and it could tell you what's going on there. Then if you had like a big content plant or something, you could say, pull me all the content where people are angry and splice together an angry reel. I don't know why you would ever want to do that, but you could do that. So that's this one, right? That's the, you sort of pull it all together idea. The last thing I want to mention before I close here is that this applies to other markets besides just the traditional M&E space that I've played in for a while. You can do home security, recognition video. You can find intruders or something, or if you have a squirrel that keeps eating your bread, then you could definitely find that squirrel and get rid of it. Government, same idea. Use recognition video for people and actions, track people. For the education and enterprise, transcribe and translate different languages, stuff like that. But the most important thing is the thing at the bottom, which is that we're only limited by our imaginations here. So anything, hopefully I shared with you a couple ideas that you could do, and it could give you any number of ideas. But you could really take these building blocks that we have and piece them together any way you'd like. And feel free to log into the AWS console and just play around with them. That's all I have. I don't know if I have a couple extra minutes, which I think I do. If anybody has any questions, sure, Scott, and then in the back. But what's up?
Can you take the transcript from speech text and closed caption video?
Yeah, you can. I don't have a demonstration of that, but the idea there is it returns the timing of the speech that it finds. And then what you can do is you could use another Lambda script to convert it into, like an SCC or SRT captions or something like that. I saw a slide somewhere that did it. So the answer is yes, you could absolutely do that. The difficult part isn't doing that. It's teaching comprehend to understand where the different sentences end. Otherwise, it's just like a whole bunch of text going, right? So you can absolutely do it, but you might have to train it to get better and better. Everybody has their own bar of excellence, right? So you could do it today, absolutely.
So are those demos publicly available somewhere?
I don't know. That's a good question.
Second question is, are those using Kinesis Video Stream at all?
No, those are not using Kinesis Video Stream at all. So that's a good question, thanks. I should have mentioned maybe Kinesis Video is another media service that AWS came out with recently, and its job is to aggregate content from, I'm going to say prosumer stuff, like security cameras and traffic cams and stuff like that. So there's a lot of Kinesis Video in the worldwide public sector. This is more for gathering broadcast stuff. So none of these use Kinesis. And I'll find out for you. I'll find you and give you a card. I'll find out if these are public. Anyone else? Or did this make total sense? Awesome. Well, thank you very much. Appreciate your time.